All right, what's going on, people? This is going to be part two of your lesson on circuits. Um, so I just want I know in the last lesson I didn't really formally define what a circuit was, so I just want to lay it out clearly. A circuit is a continuous path, excuse me, I'm going to start over. A circuit is a continuous path of electric conductors or metals, and they need to be connected to a battery or power source. So here I've got an example circuit down here. We've got a battery, we've got a light bulb, and we've got one thing that we're going to learn about today, which is a switch. And so I'm going to turn that into a circuit diagram over here. We've got our light bulb, battery, and switch. So remember that this is the battery. We represent that with a long line and a short line. In this diagram, this is actually two batteries end to end. So it's not exactly the same as the one on the left here, but you get the idea. It's a long line and a short line to represent the battery. Um, remember that the light bulb, that's a circle with an X through it. And then the switch, which you can use to turn the circuit on and off, is represented right here. And that's the first thing that we're going to learn about today is switches. So a switch is a part of a circuit that can be open or closed, right? Um, When the switch is closed, the current can flow through the circuit because the connection is continuous. So when the switch is closed, that means that the circuit is on. Um, when the switch is open, electric current cannot flow through the circuit because the connection is disconnected. Um, so here's, I would like you to draw these on your notes here. This is an open switch where the connection is broken. And so this one, the circuit would be off. And then down here, this is a closed switch, and the circuit is connected, so this circuit would be on. Just a reminder, a conductor is very good at conducting electrical current. An insulator will not conduct electrical current. And a material that only partially conducts electric current is called a semiconductor or a resistor. So usually when we're talking about circuits, we call those things resistors. In chemistry, we called them semiconductors. Um, okay. And so here's how the symbol for how we represent a resistor in a circuit. So you can add that to your notes. So example one, let's draw a circuit below. The circuit must contain a battery, a light bulb, and an open switch. You must also indicate the direction the current is traveling if the current is flowing. Oh, I said that twice. If the current is flowing, didn't mean to do that. Okay, so here's the circuit. First going to add the battery. Then we're going to add a light bulb. And then last, we're going to add an open switch. Now, because the switch is open, right, the circuit is not going to be continuous, right? The electricity would normally leave from the positive end and come around, but then it's going to stop when it gets to the switch because it can't move from this point to this point because the switch is open. So this one's going to be no current. So you don't actually need to draw anything, just indicate that there's no current for this one. Example 2, draw a circuit below. The circuit must contain a battery, a light bulb, a resistor, and a closed switch in series. So remember, that just means like one after another. You must indicate the direction the current is traveling if the current is flowing. So we'll start with our circuit. We'll add a battery. Next, we're going to do the light bulb. I put that down here. Next, we're going to do the resistor. So I added that over here. And then last up is the closed switch. Now, I didn't do them in the same order that I listed them out in the problem. That's fine. As long series just means one after another, but it doesn't necessarily matter which order they go in. Because the switch is closed on this one, there is going to be current. Remember, it always starts at the negative end and then works its way around to the positive end over here. And so in this case, the direction will be clockwise. for the current. Okay, last example. You're going to draw the circuit below. The circuit must contain a battery and then two branches in parallel. The first branch must contain a light bulb, and the second branch must contain a resistor. You must also indicate the direction the current is traveling through each branch if the current is flowing. So we've got our circuit, and then we've got our battery. We've got a line down the middle of our circuit to indicate that there's two branches. So then we'll add a light bulb on the first branch. On the second branch, we'll add a resistor, right? And it doesn't really matter which branch you're calling the first branch. So if you put the resistor over here and the light bulb over here, that's fine. Doesn't really make a big difference. So then we must indicate the direction the current is traveling. So remember, it always goes from negative to positive. So on the first loop, it would be moving like this. And on the second loop, be moving like this. In both cases, it's moving clockwise. So we follow it around, it'll go like that. On the second branch, as we follow it around, it'll go like that. Okay, and so then go ahead and try the practice problems. If you have any questions, let me know.